Assalamu alaikum. Welcome to lecture number 10. My name is Muhammad Arif Aziz. Today we are going to start with the shear force and bending moment diagram problems. Before start the problem, we have to have the basic concept of the graphical method. To explain how to draw the shear force and bending moment diagram using the graphical method, this is the objective of this lecture. Graphical method for constructing V and M diagram is simpler than method of sections, particularly in cases where a beam is subjected to several loading. Graphical method is based upon the differential relationships between distribution load and shear force and moment. Before starting the movement diagram or anything, shear diagram or movement diagram, we have to know the assumption what we are going to what we are going to assume regarding the sign convention. There are four sign conventions we have to keep in mind, which is upward and downward forces, number one and number two, downward and upward force. When the force is acting downward, we will consider it as a negative one. When it is acting upward, we will consider it as a positive one. For external couple or movement direction, if it is counterclockwise, it is negative, and if it is clockwise, it is positive. So these are the assumptions we have to keep in mind before starting the problems in this one. Okay. So we start with the problem number 1. So here we have a problem number 1. Draw the shear force and bending moment diagram for the beam as shown below. So there is a beam. There is a beam with two supports A and B. Okay. At A, there is a hinge support, and at B, there is a roller support. There is a load of 10 kN acting at point C, which is 3 meters away from A, and there is an internal couple movement of 6 kN counterclockwise at point D, which is acting 2 meters from support B and 7 meters from support A. Okay. So first of all, for the solution of a problem, we have to calculate the support reaction. Calculate support reactions. Okay. Now, to calculate support reaction, we have to make the free body diagram first. Okay. I think go to the whiteboard, it is better. So first of all, we have to calculate the support reaction. Calculate support reactions. Okay. First of all, we have to make a free body diagram. The free body diagram, here we have A, support A. Here we have support B. So it will be BAY. It will be BY. At a distance of 3 meters, we have a load of 10 kN. And at a distance of 2 meters from here, we have an internal coupling of 6 kN counterclockwise. This is point D and this is point C. This is our free body diagram. So the distance from here to here, here to here, and here to here is 3, 4, and 2 meters respectively. Okay. Now, summation of moment at B is equals to 0. Our assumption is clockwise, anti-clockwise, positive. Okay. Now, this AY will create a moment clockwise. So 9, what is moment? Force times distance is equals to moment. So 9 into AY minus plus 10 this load into this distance 6 because it is creating movement. See, it is moving clockwise, huh? It is creating movement clockwise. 10 into 6 plus 6, this moment, is equals to 0. So our AY will be 7.33 kilonewton. Now, time to calculate BY. If we assume summation of forces in the y direction upward positive is equals to 0, then AY plus BY minus 10 is equals to 0, where AY is 7.33. So BY will be 10 minus AY, which is 10 minus 7.33 is equals to 2.66, sorry. 2.66 kilonewton. This is also kilonewton. Okay. So we have AY 7.33 and BY 2.66. Clear? Now, time to draw shear force bending moment diagram. So this is our basic platform in which we will draw shear force and bending moment diagram. Here we have support A. Here we have support B. Okay. And the value of AY is 7.33. We calculated. And BY was 2.66. So this is 10 kilonewton and this is 6 kilonewton meter. This is point D and this is point C. So to start a shear force bending moment diagram, shear force is an element which is in the direction of Y. You can say that it is in the direction of Y. So we start from 0 line. Suppose this is a line for the shear force diagram. Shear force. Okay. And this is for the bending moment. This line. Okay. Now we start from the point A, where we say that our assumption for V upward is positive and downward is negative. This is our assumption. Okay. So this is V. Here at 0 line, the value of V is 0. Okay. But we start from point A. The value of A is 7.33. Okay. So you can see that from here to here, there is no load applied. So the line will be straight. But when we reach to this point, we have experienced a load of 10 kilonewton downward. So our equation will be 7.33 upward positive minus 10. So it will be 2.66 with negative sign because we consider sign of the greater value. So here our value of shear will be negative 2.66. So above the 0 line, we have the positive value. Below the 0 line, we have the negative value. So our 2.66 will be here. From here, then here, till from point C to point D, we are not experiencing any shear force. There is a movement at this point, but we are calculating the shear diagram. So we will make a straight line. When we reach to this point at 2.66, we experience a load in the upward direction 2.66. So our equation will be minus 2.66 plus 2.66 is equals to 0. So our figure will be close here at 0. So this is a positive zone. This is a negative zone for the shear force. And this is known as shear force diagram. Okay, this is known as shear force diagram. Let me hatch this one so it will be more convenient. This is our shear force diagram. Now, time to calculate bending moment diagram. For bending moment diagram, we start from the zero line. So here the assumption is below the zero line, negative value. Above the zero line is positive value for moment. Okay, same assumption. Now we start here from the zero. What is moment? Moment is force, time, distance. Okay, and area under the shear force diagram, any area under the shear force diagram is moment. So from this point to this point, which area is under the shear force diagram? Area under the shear force diagram is this one. This body is rectangle. And what is the area of rectangle body? Area of rectangle body is length into breadth. So it will be, suppose if it is length, which is how much? I don't remember. I think it's 3, 4, and 2. Let me check in the. Yeah, it is 3. It is 4, and it is 2 meter. Okay. Now, what is the length here? 7.33 into breadth is 3. So your answer will be almost 21.6 or something, or 22, almost 22. Okay. And the unit here is, what is the unit here is kilonewton meter. Okay. This is a unit of kilonewton meter. This is a unit of moment as well. So we have a straight line of first degree, which is 22 here. Now we have a negative moment, or you can say we have a area under the shear, which is negative. So we have to subtract 22 minus this area. So our equation will be 22 minus this area. How much is this? How much is this area? 2.66 into 4. When we do that, solve it, our answer will be 11.36. So, and it is positive. So our moment will be positive 11.36. Then we have a counter movement. So we remember the assumption we said that we have to assume it negative. So 11.36 minus 6, it will be 5.36. So 5.36 will be positive and it will be act here. Now to close this loop, we have left only this body. So what is the area of this body? 2.66 into 2 minus, and here the answer is 5.36. So 5.36 minus 2.66 into 2. So it will be 0. So our value will be 0 and it will be close at 0 actually. Control Z. So it will be close at 0. Okay. So this is the moment diagram and all is positive. So we will hatch it as well. So this is area under the moment. Okay.